Hello, this is Christoph Broing from Munich, Germany, and today I'll show you around our machine learning inference capability provider and the application we build around it. So in that architectural drawing you hopefully see here on the screen, you'll see a picture of the application. There's in the center, in the big rectangle that illustrates our wasmCloud runtime, there are multiple artifacts. The smaller rectangles that are capability providers. We have got an HTTP server, and that is also an endpoint to the application on the lower left. And on the top right, we have the capability provider, which does the inference processing, so the machine learning processing, and it's marked IE. That's for inference engine. However, that's misleading a bit because we already have more than one inference engines implemented in it. However, now you know what it represents. Then in the wasmCloud runtime in form of circles, you have actors. We have two of them here. The one is API, so inference API, that's directly connected to the HTTP server. And the other one marked I, you can imagine it not being there. It's not implemented. We intended that for first iteration of the application. It's not important. Outside of that wasmCloud runtime, you've got the Bindle server. The Bindle server is a kind of a blob store, and that's where we used to store the AI models as well as some metadata. So what happens is if you process requests against that wasmCloud runtime, they come into the HTTP server, are routed via the inference API to the capability provider who does the processing, and the response going back via the inference API and the HTTP server, so that you will receive hopefully a 200 OK response with the result of the inference processing. However, as I said before, the processing can start, the capability provider, i.e., has to download all the models, and that is done during startup of the application. So having said that, let's see how we can get you up and running such that you can replay what's already pre-configured in form of different models and also scripts in the repository. Don't worry about the repository URL. You can ask for it in the Slack channels, and I think you will get a quick response. So one of the preconditions is that you have installed Bindle server. As far as I know, you can install any version node. However, that versions later than 0.7.1, you have to deal with keys, so they harden the security aspects. So for development purposes, I use 0.7.1, and you do not have to worry so much for security. What else do you have to install is that Docker and Docker Compose. I referred to the page of wasmCloud. They have got a good guide, what you have to take care of and what you have to install. Otherwise, we may directly jump in and start the application now. Let me see if I have it ready for us. So before you can replay the application, as I said, you have to load the Bindle server with the models. So luck for you, for us, the models are pre-configured in the repository. So let's see how you load them up into the Bindle server. Once you have cloned the repository, go into the deploy directory, and then we have a start script called run. This is your friend. If you just type it, you get all the subcommands. And in order to upload the pre-configured model, run Bindle create. So it will create the it will upload the pre-configured models, upload them to the Bindle server, which is started at the same time. So you do not have to worry to start it. And then you should be good to go. You get some log information. And if it looks like that, this is fine. You have to do it only once. So once you've uploaded the models and the metadata to your Bindle server, you do not have to do that again. So whenever you start or stop the Bindle server next, you can do it with the other subcommands. You see Bindle start and Bindle stop. So that's started now. It's time to start the application. And that is done via run all. So what's starting is NUT server. We have a local registry where we pull the actors and capability providers from. Of course, the runtime itself, and the Bindle server is already running. So now if you go into the log directory of the wasmCloud host, you can see, hopefully, files named erlang.log.something. And if we print them out, you can follow up the logs. So while the application is starting, we may have a look at the washboard, which is getting more and more complete. What do we see at the washboard? We see the application starting up with all its technical stakeholders. So at the top right, we already have the ML inference capability providers. You see its status is healthy, so it's up and running. On the lower left, you see two links. So one link is between the HTTP server and the inference API actor. The other link links the inference API actor to the inference engine, so to the capability provider who does the processing. And the inference API actor itself, you see in the top left. So meanwhile, the HTTP server started up, its status is healthy as well. It takes always a bit longer. So now we are up and running. That should be reflected in the logs as well as in the output. And now let's have a few requests running. So I've pre-configured 2 requests. The first one is a request against the Onyx inference engine. Its model is called identity. What it does is, so the model is configured such that the output of the model is always the input, so it yields what it gets. It's not particularly interesting for real-world use case. However, in case that works, you know that the application is up and running and works well. And if we trigger that, you see we get a 200 back, and also we get a result. And if you compare that result, you see a field has error is false, so that's good already. If you compare the content, you see that the content is identical, in fact, to the request. That's fine. So that's a request against the Onyx engine. Now we also support TensorFlow engine. So we've got a second model. It's also pretty, say, simple. However, not another identity model. It is a +3. It adds 3 to every field in the data, what it gets. So let's just post it. See that we get back a 200. And now if you closely compare the data of the response to what we put in as a request, you see that's not identical, in fact. And these data, I mean, that is serialized to byte array. But if you deserialize it, don't know if I have it prepared for now, you will see that, in fact, there's a +3. I scroll down the README of the current repository, and there we have it documented somewhere. So this is exactly what we got back. And if you deserialize that into F32, you see that it incremented, now it's down here. So it incremented every input by 3. That's why it's called +3. Yeah, that's it. That was the 2 examples. So if you want to replay that, have problems, or if you want to implement your most wanted feature, contact us in the Slack channels. And that's for now. Thank you. Bye.